Hi, hello everyone. Welcome back to this deep learning video lecture series. This is Dr. Chiranjeevi Manike, Professor in Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. And previous lecture, I just explained I gave just a brief idea about the fundamental packages that is need to be practiced before we develop deep learning models. We discussed about pandas, numpy, and matplotlib. These are the three fundamental libraries, and we have to know the concepts and mainly how to create matrices, matrix multiplications, and like different functions and the attributes, etc. So you have to practice a lot so that you could remember all those concepts. And even like in deep learning models also, we will not design the entire code. We will make use of the libraries and packages and etc functions. So directly we can invoke the functions and we can pass the arguments. So but we must and should know which function and what is the purpose of it, and like what is the libraries and what parameters need to be passed and what are those parameters. That is the minimum thing. So that is minimum required to design and understand, mainly to understand and design the deep learning models. So now in this lecture, I'm going to discuss about the two other important, but there are four I just going to present here. One is a Keras, next TensorFlow and PyTorch. These two are the important libraries for deep learning models, and also the scikit-learn. Let us see one by one. So here, why means which library is suitable and what are the benefit features of that particular library and where it is suitable. Like all those concepts will be explored here. So first, let us see what is the Keras. It is all these the libraries and are the open source libraries. So this Keras offer a Python interface for building artificial neural networks. Whatever the libraries we discussed, like Python, NumPy, and Pandas, Matplotlib, now the Keras, TensorFlow, PyTorch, and the scikit-learn. These are all the Python interfaces for building the artificial neural networks. So this Keras initially developed as independent software, but later it was integrated into the TensorFlow library. That is to expand the support, that is to additional frameworks. It is a high-level application programming interface, mainly for building the neural networks. It was originally independent, but now integrated with a TensorFlow. So that's why you have to just remember only the PyTorch and the TensorFlow. So easy to use and the fast prototyping. These are the features of this Keras. And next, another library, that is sklearn. This is also called as a scikit-learn. Initially, its name is a scikit-learn, and this is also known as a sklearn. It is a widely used open source machine learning library for Python. It's built on top of and integrates with the commonly used libraries like NumPy, SciPy, Matplotlib, Pandas. So all this makes it accessible and versatile. Next, important library, that is we can say it's a tool, a software tool that is to develop the deep learning models, and that is a TensorFlow. So this TensorFlow was developed by the Google Brain, and it supports the deep learning and the machine learning workflows. It offers both the high level, that is Keras, and the low level application programming interfaces, mainly optimized for the CPUs, GPUs, and the TPUs. And if you look at the features of TensorFlow, that is, one is a tensor board. And what is a tensor board? Tensor board is mainly, it's a powerful visualization tool for TensorFlow that helps to monitor and debug the deep learning models. Let us see what are the features of this tensor board. So the features of tensor board includes mainly the tracking and the visualization metrics. Like as we discussed, like in the real world, the artificial neural networks will have many number of layers, many number of neurons in many number of units or neurons in each layer. So the models are more complex because the billions or millions of parameters will be tuned. So the tracking and the visualization would be more useful, that is with the help of this tensor board. Next one is visualizing the computational graph. Next, viewing the histograms and displaying the multimedia data. That is, multimedia data is nothing but audio, video, images, etc. And profiling the TensorFlow programs. So these are the features of this tensor board of the TensorFlow. Next one is a PyTorch. So this is another which is almost relevant TensorFlow. We'll discuss the key differences between this TensorFlow and PyTorch. So by the end of this session, you will get an idea of which is right. Like suppose if you are a beginner and if you are already doing the research, then which is the best and where this particular library is suitable. So PyTorch, it is developed by the Facebook's AI Research Lab, in short like a FAIR. It's a dynamic, it has a dynamic computation graph. We will discuss what is mean by this dynamic computation graph and the static computation graph. So, and which this dynamic computation graph of this PyTorch makes it more flexible than the TensorFlow. So dynamic means we can change dynamically, like any parameters we can change it, we can do some adjustments, we can add some, so the fine tuning would be done dynamically. So that is the main feature of this. So it's why that is the reason the PyTorch is more flexible than the TensorFlow. Next, a strong support for the research and production. Mainly it is used for research and academy, and widely used in academy and the industry. And next, another the differences. If you look at the key differences between the TensorFlow and PyTorch, and one thing we need to understand, that is data parallelism and model parallelism, because we are in the big data era, and also the deep learning models. If you want a deep learning model to perform more accurately, we have to train the model with the huge volumes of the data. So if then there will be two challenges. Like as I said, the neural networks, if the number of layers, like input layer, output layer, and the number of hidden layers are more, and the number of input parameters, that is in each layer the number of units are more, and so then the model complexity would increases. So that is one challenge. Another one is the data, because we have to train these models on the huge volumes of the data, so that data may not fit into that, but whatever the computing environment we are using. That means we cannot store, suppose let us say I have a laptop of some 16 GB RAM and 1 terabyte of a hard disk. So, and the data which I need to the data which I will use to train this deep learning model may not fit into this laptop. So in that case, we have to go for the solution. So that the solution is distributing the data set. So splitting the data set and distributing across the different nodes in the cluster. So that means, that is, if the complexity, the model is more complex or the data is large. So based on that, we will go for whether we should go for a model parallelism or we should go for data parallelism. So let us see what it does, like a data parallelism and a model parallelism. So data parallelism, that is distribute across the nodes. So we have to, suppose we have huge volumes of data, and that data will be distributed across the nodes. Next, whereas the model parallelism, that means model is more complex, so it would take a huge amount of time and also the resources. In that case, we distribute the model parameters across the devices. So these are the two ways, like whether we could go for data parallelism if the data is more, and model parallelism if the model complexity is very high. And how it works, so here the data parallelism so replicates the model across the GPUs. That means we like suppose we have a data set, and that data set is so large, so then we split this data set into the like different parts, like suppose this is part 1, 2, 3 and 4, and then we distribute this data across the nodes in the cluster, because in okay, these are all connected, these are all connected, all the nodes in the cluster are connected. So, and each, like suppose we distribute this data, like the block 1 are the segment 1, data segment 1, and this is 2, and this is, like we distribute the data across the nodes, and then we replicate the model and across this, like suppose these are the GPUs, like these are the GPUs. So then we'll distribute the data, like if there are 4 GPUs, then we will distribute it into the 4 parts and distribute across the node GPUs, and then replicate the model, whatever the model we have. So then then we will we'll train the model. Next, whereas the model parallelism, that we partitions the model across the GPUs. So we'll divide the model into the different partitions, multiple partitions, and then we use across the GPUs. Okay, in that case, the same data set, but the model would be partitioned into the multiple. Next, if you look at the benefits of this data parallelism and model parallelism, so data parallelism, that is efficient with large number of weights, whereas model parameter, it trains the large models that exceed the capacity of individual devices. Okay, so that means if the model could not be run on an individual device, so then we'll go for a model parallelism. And if you look at the key differences between this PyTorch and TensorFlow, and like let us see the differences. So the one thing is easy of use, how easy that particular library. Like PyTorch feels more like a native Python, and it is preferred in research, whereas a TensorFlow requires more learning, but it is widely used in a production environment. So next one is a computation graph, as we discussed just now, like a dynamic computational graph and the static computation graph. So TensorFlow uses a static computation graph that is optimized for the speed, whereas the PyTorch uses the dynamic graph that is mainly better for debugging. So we can randomly change the parameters. That means we can tune the parameters dynamically. Next, deployment, like TensorFlow has built-in tools for the production. So while the PyTorch requires additional steps. Next, industry use, TensorFlow dominates the industry applications, while PyTorch is more popular in academia. So, and let us dig a little bit deeper to understand the main differences between the TensorFlow and that else it would be considered as a summary. Like, so here we are going to understand the differences mainly, like PyTorch and the TensorFlow. So, and the TensorFlow was developed by the Google, whereas PyTorch by the Meta, Facebook. And popularity is TensorFlow is widely used in production environments, whereas PyTorch preferred for research and experimentation. And flexibility, it's more rigid, and whereas PyTorch is a highly flexible. So, and the APIs, application programming interfaces, and easy of use, whereas TensorFlow offers both a high level and a low level APIs, where PyTorch uses a low level APIs and is more Pythonic. And learning curve, as the PyTorch is generally easier for newcomers, whereas the TensorFlow is steeper for beginners. And programming approach, like a static computational graphs, And whereas in PyTorch, it has the major advantage with the PyTorch is a dynamic computation graphs. Next, easy of use, slightly complex for beginners, that is TensorFlow. So they have to spend a little amount of time. Whereas the PyTorch is that is beginner friendly, that is completely Pythonic. And deployment options, and the TensorFlow is great for mobile and embedded systems, whereas PyTorch is limited deployment options. So next, debugging tools. Like built-in tensor board we have, that is for mainly visualization in the TensorFlow, whereas PyTorch debugging tools like a PyCharm we have. And the ecosystem mostly used in a TensorFlow mostly used in a production and the large scale projects, whereas PyTorch better for the research and prototyping. So these are the key differences between the PyTorch and TensorFlow. So we would say just in short, if you are a beginner or a researcher, the PyTorch is easier to learn and easy use. And if you are working on large scale deployment, so the TensorFlow would offers the better production tools. So thank you for watching this video.